Good morning, students. Today we all will be learning about the conductometry and its type. So first of all, in the last lecture we have learned about what is conductometry. Now we will talk about the types of conductometric titration. So the conductometric titration consists of the acid-based or neutral titration, which has 4 points: strong acid, strong base; strong acid, weak base; weak acid, strong base; weak acid, weak base. Second titration is replacement or displacement titration. Third, redox titration. Fourth, precipitation titration. Fifth, conductometric titration. And last one is non-sequence titration. If we talk about the strong acid and strong base titration, and this, there is a fall in the conductor due to the replacement of hydrogen ion uh, by the sodium ion. Then, after there is an increase in the hydroxyl ion, which leads to the rise in the conductance. So, as you all can see from this graph, the blue line represents the conductance of HCl, that is a strong acid, and this red line shows the conductance of sodium hydroxide, which is a strong base. So, all you can see that the conductance started to fall, and after this, as differed by the sodium ion, and after some point when OH negative ion increases, the conductance goes up, and this point is known as equivalence point. Then second titration is strong acid weak base titration, in which there is a fall in the conductance due to the replacement of hydrogen ion by ammonium ion, and after the point there is constant conductivity due to the suppression of ammonium hydroxide by NH4Cl. So the blue line here represents the strong acid and the red line represents the weak base. Strong acid is the HCl, hydrochloric acid, and the weak base is ammonium hydroxide. So we all can see that there is a fall in the conductance as shown by this blue line. But after the suppression of ammonium hydroxide by ammonium chloride, then there is the steady in the conductivity. We talk about the weak acid and strong base, and there is an initial decrease in the conductance, but after some point it increases due to the presence of sodium hydroxide. As it is can be represented by blue line represents the weak acid, the red line represents the strong base, and the last curve is of the weak acid and weak base of acid-base titration. So there is increase in conductance due to the excess amount of acetic acid, and thereafter there is suppression of ammonium hydroxide by acetic acid, which leads to the constant conductance. Here the blue line represents the weak acid and the red line represents the weak base. Now comes the second titration of conductometric titration is precipitation titration. So as compared to the acid-base titration, precipitation titration is not much that accurate because it has large numbers of interference in it. This precipitation titration is also known as replacement titration. The precipitate formation, which is formed at the end of the reaction, which means that at the point when there is the formation of precipitate, it means that the titration has achieved its endpoint. And when the precipitate is formed and the endpoint is being achieved, at that point the conductivity is being measured. We have learned this graph by an example. So in this, the potassium chloride being titrated against the silver nitrate, which gives silver chloride in precipitate form and potassium nitrate. Initially, when there is addition of silver nitrate to the potassium chloride, it shows their stability in the conductivity. Okay, but when there are large amount of, or we can say that excess amount of silver nitrate is being added to the potassium chloride, then there is a sudden increase in the conductivity, which is can be seen by this graph only. There is stability at the starting when silver nitrate is being added to potassium chloride, but when the excess amount of silver nitrate is being added, there is sudden increase in the conductivity. Okay, and we can also learn this by another example. So in this the first case, we talk about the potassium chloride and silver nitrate. There is formation of only one precipitate of silver chloride, but there is the formation of two precipitate. So in that case, we talk about we take magnesium sulfate and barium hydroxide. They are being treated against each other, and they will form the two precipitate, which is magnesium hydroxide and barium Sulfate. Initially, when this titration takes place, there is an decrease in the conductivity, but at the end, when both the precipitate are being formed, that is magnesium hydroxide and barium sulfate, after that, there is sudden increase in the conductivity, which is being shown by this graph. There is sudden decrease in the conductivity, but as soon as both the precipitate are being formed at the end point, there is sudden increase in the conductivity. We talk about the redox titration. So in this, there is decrease in the hydrogen ion concentration, which shows there is decrease in the conductivity when it reaches the end point. Okay, we have learned this by an example, that is ferrous ion with dichromate ion. So when this ferrous ion titrated against chromate ions, it forms ferric ions and the two chromium ions, 7 molecules of water. So the hydrogen ion shows sharp decrease in the conductivity, and when it reaches the equivalence point, there is addition of the excess amount of the titrant, which show there is this stability in the conductivity, which is shown by this graph. That whenever the titration started of ferrous ions and chromate ions, there is decrease in the conductivity, but as soon as it reaches the end point, due to the presence of excess amount of titrant, there is stability in the conductivity. And then we talk about the complexometric titration. So in this method, it is different from other titration, that in every titration we have only one endpoint. But in complexometric ion, we have two endpoints. And these two endpoints are due to, the first endpoint is due to the formation of metal ion, and the second one is due to the formation of complex. We have learned this complexometric titration in conductometric titration by an example of potassium chloride with mercury chloride. So when mercury chloride is treated with potassium chloride, it forms mercuric chloride and two molecules of potassium and potassium chloride. When this mercury chloride and potassium reacts with each other, it forms a complex of potassium mercury chloride. So there is initial endpoint is shown by the formation of mercuric chloride, and then there is stability, and as soon as the second endpoint is reached, which is due to the formation of potassium mercuric chloride, there is sudden increase in the conductivity. And now the last titration is the non-aqueous titration. So this is carried out the same as the acid-base titration, which is being used by non-aqueous solvent. As we all know that in non-aqueous titration we use solvent other than water. It gives an examples of when a weak acid in methanol is being treated with dimethyl ammonium hydroxide, or we can say that a weak acid or a weak base is an example of non-aqueous titration. Thank you.